Hello everybody, this is David Cuartielles, co-founder of Arduino, transmitting today on Monday 14th of May 2018 after this fantastic weekend where we celebrated Arduino Day 18 in Milan and other 530 something places in 94 countries, which was fantastic. I'm here today to celebrate European Maker Week. We're going to be celebrating European Maker Week hopefully the whole week, except maybe tomorrow for personal reasons, but I will try to make a livecast every day this week for about an hour a day, where I will be trying out different things. And I'm going to be wrapping up different projects that I started, different livecasts, and trying to code different things. So it's going to be more of a making kind of livecast than the traditional kind of thing that I'm doing when I'm presenting something specific and so on. So what we're going to be looking at this week is going to be these shields here that I mounted last week, and the idea is that we will be there are shields from Nootropic design, as you saw on the previous image, and I chose this one for no particular reason. I have to say I bought these two shields that are made. It's called the AudioHacker shield and the DJ shield. And I bought them almost a year ago, and I never had the time to put them together because I was studying for my doctoral thesis. And finally last week I took the courage and I took a break from studying, and I decided I need to put these things together, and I soldered them during the livecast. And what I'm going to do now is that I'm going to be trying the libraries to make sound with them, and I will hopefully make them work. And Michael from Nootropic Design, if you happen to be around and you want to join the chat, up there you can see the chat on Discord where you could join us and help us out. And if not, I'm pretty confident that thanks to the instructions that are online, I will be able of making it work. This is going to be more of a David trying out things kind of livecast, so I might not be talking as much as all the time. So if you're interested in this, you can put me in your background, and at some point in a while, I might be able of making some noise. As usual around me, and I'm going to just move my camera real quick, I have a lot of stuff on my desk, so soldering iron is not going to be needed, but it's there. I have some Italian mint juice that I bought the other day while at the Arduino Day. I have a beard, and I have a mixer board and a lot of cables that I can use to connect to the shield that is here. And as you see, I have already connected an audio output that will go straight into my mixer board. And just to remind you about what I have here, here I will just first disconnect this from the computer. I have an Arduino Uno, and on top of the Uno I have mounted the AudioHacker shield from Nootropic Design that looks like this. Okay, and it has an audio output and an audio input, so this output is the one I'm putting connected to my mixer board. And on the other hand, I have the DJ shield that has a bunch of knobs and buttons, and I even have the knobs here that I have to screw. So everything is exactly as I left it in livecast number 11, mostly because I haven't had any time to do anything about this, which means basically I am going to experiment live, and I have no idea how this is going to work. I'm just going to do my best, as I said, to make it work, and honor the work that Michael did in putting this thing together. And for future reference, if you are interested in getting me or anybody at Arduino to try things out, you're welcome to send us stuff. Just to make it clear, Michael didn't send this thing to us to make any kind of marketing or anything like that. I bought it from him and he shipped it to me. We had a maker to maker relationship in that sense. And he didn't know I was going to try this out. I never told him I was going to do it. So, just to be completely clean out of this one. So nobody comes and says, oh, these guys are paying. No, that's not the case. So as you know, I have a computer. If you're following the livecast, you will know that I have a computer that runs Windows 10. I'm not a Windows person, but I use it because it's easier for me to run the livecast at this point. That also means that some things don't work as I expect. So sometimes my libraries don't compile, and it's because I'm not used to work with Windows. So I don't want to blame the computer or the operating system in any way. It's just about me being more of a Linux guy, trying to scout the world in Windows. And that's interesting because many of you sometimes try new things and you would like to know how it feels. So you might hear me cursing during the livecast. It's nothing personal. Okay, so we're gonna start. As I said, we have the shield there, we have a mixer board down here, and what I would like to do is to get some sound out of it. And what I'm gonna show you then is, oops, oh, surprise, there should be a browser window there. You don't see it. Let me just fix this in a second live as we are transmitting, and here you go. So now you see a browser. Okay, so this is the browser, and it's at the Nootropic Designs website. That is a website where you can find information about different projects and products that are designed by Michael and his people. And the one I have here is the AudioHacker shield for real-time audio processing, and on top of it is this DJ shield down here. And you see there is other things like a really funny diffusible clock, so it looks like it's something's gonna blow up, but it will not. But you can, you know, buy it and give it to a friend or whatever. So I found this at Dindy, and I got myself the AudioHacker because I'm really interested in noise production, just for personal fun reasons. And on top of that, I got the DJ shield because it looks pretty cool. So the way this works is that there is, just to remind you, this shield has a digital to analog converter, an analog to digital converter, a sound amplifier down here, and two memory chips. So I am assuming, when I look at the schematic, is that it's possible to bring in sound through the input, record it in the RAM, and do something out of it, like adding reverb or echo or whatever other effects, and then push it out. And if you read the instructions here on the right hand side, it says that it can do high quality 12-bit ADC and 12-bit DAC, which means you can take samples at 4096 and it allows for real-time ADC and DAC at 44100, which is CD quality, which is one pretty high digital quality for this. We have 256 kilobytes of RAM that allows recording audio samples, so you don't need an external SD card. And since it's high-speed SRAM, it allows to really fast access audio data in real time to do audio processing, and it allows you to record about 9 seconds of high-quality sound at 22 kilohertz, which means that if you obviously change the quality, you will be able of recording more sound. Then the operational amplifier provides high current output and up to 100 times gain that you can control with this potentiometer that is down here. And there is two onboard buttons for input, a bypass switch, a volume knob. Volume knob is up here, the bypass switch is down here. So the shield by itself, the AudioHacker shield, without the extra DJ shield, already does a lot of stuff. And you can connect a 3-volt battery backup to retain the samples in memory. So if you want to record samples and keep them here, there is a battery connector that you can use up here, and it's compatible with Uno, 2009, Mega, and Leonardo, and it's using the pins 5 to 13, which means all of the other pins are available for you to use for whatever. For example, the analog pins to read knobs, just to mention something. It's easy to assemble, and you can even order it pre-assembled. So I ordered it to be the one to assemble it myself, and I had quite a time assembling it the other time. I have to confess, I like to solder. It's not something I want to do for a job, but I like to solder every now and then, and sometimes it's very cathartic to spend a couple of hours building something, following a tutorial step by step, and getting something done that looks cool. This is the case of this package here. Okay, so what you can expect, and let's see if you can hear what you can expect from it. This is where I stopped last week. I tried very quickly to make something work, but as I said, I hadn't rehearsed, and I have been soldering for an hour and a half, and it really felt like I had to finish the program. So I stopped with the hardware, and today we will continue with the software, and this is the kind of thing you can expect. Let's see how it sounds. Okay, I suspect that you're not hearing anything because I'm not hearing anything. So I will I'm realizing that the volume is really low, so let me just...
AudioHacker voice changer project. AudioHacker voice changer project. AudioHacker voice changer project. AudioHacker voice changer. Hello, 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 hello.
Okay, I guess you get the idea. This is what the kind of things you can do. I don't have a MIDI keyboard, so we will not see that example today here, but I will try to do as much as possible to see what it does. And as I said, this is basically me, David, trying something new out. I haven't prepared anything, so if you never try to keep yourself, you know, this is how I go about trying new things. So I mount the thing and then I read the instructions. I don't always read the instructions first. So I'm going to be reading the instructions aloud as I go, so I can learn how it works, and I will at some point have an eureka moment when I will realize what I was doing wrong or what I should be doing differently. Okay, so first of all, as you see here, there is the some features, extra features, like the input and output have extra pads, so you could solder wires in case you wanted to have a different kind of connector, or just have like a permanent connection to something. The bypass switch allows you to hear the input signal directly on the output, so this could be used to check whether the system is working. So I guess it's an electrical bypass, so this means that if I connect a microphone or a sound source to the input and I click on bypass, I should be able of hearing it at the output without doing any effects on top of it. There is a couple of buttons connected to pin number 5 and 6, so I could do make use of those buttons to do things with them. Yeah, there is an echo in my voice. Okay, let me just try to fix it for a second. What about now? I think the echo seems kind of gone. Am I mistaken? Yeah. Okay. Then there is a volume knob that can be used to control the volume of the signal as it's processed, and there's a preamp gain for the signals coming in. So as it says here, if there is a preamplified signal coming in, like from an MP3 player or whatever, it should be put to 0. In this case, I do have an external microphone that looks like this, a tiny microphone that I will try to use, and we'll see whether this produces any kind of effect. Oh, now I can see the echo. Let me see if I can filter this out for a second. Echo. Yeah, I think it's mostly on the low frequency range. Let me see. Echo. Yeah, if I cut the gain. Yeah. Oh. Pretty nasty echo actually. Echo. Can you hear me now? Okay. Right now I think I managed to eliminate the echo, but I'm not exactly sure if it's perfect now. Okay, great. Yeah, this was the thing. Yeah. I have to say this room is used by multiple people, so probably somebody has pressed the wrong button on the mixer board, and I've been talking with echo for a while. Okay. So thanks for correcting me with this. I still keep learning. Okay, so as I said, there is a preamp gain. I'm going to use a microphone, so probably the gain should stay as it is. And as I said earlier, there's a battery connector that can be used to keep the sound samples stored in the RAM memory when you stop working. And as it says here, a 3-volt coin cell battery will be sufficient to keep the data in memory. So if you were playing in for example, a gig, and you wanted to keep the nice samples you did today, it would be a good solution to just keep them there and then eventually record it somewhere else. Because the thing that this shield collection lacks is an external way of storing the results in some sort of like memory chip, so you could eventually use it later. So there's a table here that gives you some information on how you have to configure the volume and the gain depending on the audio source you're going to use. So if you use a computer MP3 player, set the computer MP3 player volume to a very high level, and set preamp to the lowest value, no gain. Okay, if you use a electric microphone, there is obviously no input volume, so just use the gain at your own will. And if you use an electric guitar, set the guitar volume to a high level and then adjust the preamp gain to desired signal amplification. So you can use this shield as it's suggesting here, for example, to be a guitar pedal for your guitar, an effect pedal for your guitar. And when it comes to the output settings, which is basically the output volume, it says here, do not connect the AudioHacker output to a large and amplified speaker. You can drive an 8-ohm speaker, but for big sound, only connect it to a stereo receiver system or amplified power computer speakers. Okay, I have a mixer board, which is the equivalent to an amplified computer speaker. That will allow you people there to hear whatever I'm mixing down here. So output devices, I have stereo receiver, power computer speakers, headphones or 8-ohm speaker, and it says here, if you send it to power computer speakers, which is my case, set the volume to the highest volume possible on the mixer board here. Sorry, on the AudioHacker shield, and then use the mixer board at whatever desired level. So that's the one I'm going to be using. So on the one hand, I need to put the gain at the high value and at the same time the volume at the low value. So I will just remove the DJ shield, and I will connect my microphone to the input. It's a brand new microphone, never used it once, so I hope it will work. So here you go, and I'm gonna clip it to my beard. There you go. And so I have a small screwdriver here to just play with the gain. I'm gonna raise up the gain, and I'm gonna raise up the volume of the output, and I will give a bypass signal and see if I get anything on the mixer board. Hello, 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 hello. So I'm not really sure I'm getting anything. So this comes on my channel number 5. Channel number 5. So I think that you guys can hear some sort of a background noise. If that's the case, it's good, because that means that hola, hola, hola. If you get a background noise, it means that you're definitely hearing the same noise I'm hearing in my headphones. That is provoked by the volume that I'm rising in this from the signal. But hola, 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 I can't hear it, which means basically the combination with this microphone isn't working. So, maybe now. No. So that's that noise that you heard is provoked by the shield with whatever program the Arduino board is having, and I'm just trying. If I click on bypass, you get like nothing, and I try again, changing the settings. So here I am raising up the gain to the maximum, changing the volume to the maximum. I don't get anything. I will put the volume to the minimum. Hola, 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 hola. So, hola, 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 hola. So clearly I'm not able of affecting the sound with the microphone. So I'm gonna try to make some noise with something else, and I should have thought about it first because I should have an audio cable to just get the sound directly from my phone, for example, and send it into the input of the shield and see if that works. So I have my phone here, and I'm gonna look for an audio cable, so just bear with me, it will take a second. And here I have a classic audio jack, male, so I can get a song out of my, or sound, whatever sound, out of my phone and play it on the mixer board. So I'm gonna debug the whole process. So I have an application in my phone that is called the Soundboard that plays different sounds. It's called Custom Soundboard, and it looks like this. And the first thing I'm gonna do is to just check whether the sound cable I'm connecting to the mixer board actually works. So here you can probably hear the sound effects I typically use in my LiveCast. So as I'm ticking one of the effects, you can hear the effects in the mix, which means we know for a fact that the sound works. So let's take a look at whether we can get the sound to play through the shield, so that we know the microphone isn't working really. And this is a pre-amplified sound player, I need to lower the gain to the minimum as it was recommended. So I'll lower the gain to the minimum. There it is. I will put the volume to the minimum. There it is. And bypass. So it doesn't work when I click something on the phone. You can hear it. I can hear it because I hear it directly from the phone, so it doesn't detect it as a device that is connected. So basically I'm having issues to connect the output from my phone into the input of the device. So I don't know whether the device isn't working as it should, or whether my cable is broken. So I'm assuming that my cable isn't broken because it's brand new and I tested it before. So it's one of the few things that I tested before coming into the LiveCast. So I wonder what else could be not okay in here. So there's the volume, and there's the gain. That's pressing the gain, lowering the gain. So since I soldered this thing last week, I haven't touched this, so I wonder whether I made a mistake and any of the soldering joints could eventually be mistaken. So I have to take a look and make sure that all of the soldering joints are done properly on the shield, especially the audio connectors. And when I look at it, I see that all the solderings are fine, and there is no short circuits on it. And you can check this yourself if you want to. You can see the soldering that I made last week, and none of the soldering joints are missing. There seem to be no cold soldering either, and there is no short circuits. So I'm going to assume that the soldering is not the problem. Then the next thing I will do is to check that I put the components in the right location. So the two RAM memory chips are on top and they are pointing in the right direction. Then the ADC and the DAC are in the right location, at least so it seems. I'm just going to double check the part list. I also want to turn off my phone so it doesn't disturb us as we are doing the live cast. So I'm going to check the part list. So there's the building instructions here in the browser. There you go. So let's see when the components are placed and the chips. I'm looking at whether the microchips are put in the right location. Here, according to the picture, the 1252 3201C, yeah, it's in the right place, and the 4921 is in the right place, and the memory chips are in the right place, and the sound amplifier is in the right place. So now I have the certainty that I mounted the whole circuit properly, and that I also made sure that the chips are in the right mounted in the right direction. So, and I did everything at first, so I haven't changed anything since the other day, so things should be operational. So at this point, there is a thing that isn't working, and I have to try to figure out what it is. So I have assumed a couple of things. I, for example, have assumed that the bypass button is bypassing the audio without going through the microchip, but maybe that is not the case. Maybe the bypass is only working when you have installed a certain program on the chip, which I doubt, right? But I'm going to try some of the examples in the libraries to see if there's anything I could do about it. And if it doesn't work, I will at least try out the other shield just to have the certainty that the DJ shield works. And in that case, just double check that everything is fine. So I'm gonna just try now with the AudioHacker shield, as you see it here on an Arduino Uno that you see down here. And I will just open the Arduino IDE that here you can see. I'm gonna just open the Arduino IDE. It's really hot in this shed, by the way. Now the summer started, I need to get myself a fan, or the LiveCast are going to be really hard. And something that I did the other day is that I installed the library for the Nootropic design, the AudioHacker library. You see here. So I already installed the AudioHacker library. I will skip that step, so I will explain how to do it again. And I'm going to try to see some of the examples of this library in particular. So here you have it, AudioHacker, and there is voice changer, sample reverse, sampler MIDI. So there is a lot of things that have to do with sound, the sound that has to be taken in. But to me, I have a hard time trying to check that out because I couldn't check whether I can get sound in. So the question is, what is that I can do to try this out? And well, I don't know whether any of these examples have anything that I could just try out of the box. So I will just go back to the documentation and just try to figure out whether there is any kind of example that could be interesting to check. Whether there's any kind of example that I can use as to test that everything works. So at the end of the instructions, this is a troubleshooting here that talks about how to mount it, and it says here aren't you sure it's not working the way it's supposed to work? Consult the usage guide. So let's take a look at the usage guide. And the usage guide is where we were actually before, and where it talks about the input and output settings and the bypass switch. The bypass switch should be in the left position, no bypass to use the AudioHacker. To hear the original signal on the output, move the switch to the right position to bypass the AudioHacker circuitry. The signal on the output will still be converted to mono, but will be otherwise disconnected from the AudioHacker circuitry. So I'm just making sure that the switch is on the left. I tried both positions when I was testing things earlier, but none of them worked. So let's see memory capacities. We know how it is. Here's some explanations about the resolution in bits and sample rate to see how much sound you can record, and issues with performance, the sound library, download the library, explanation how the library is working, and so on. So theoretically it should be possible to read the signal and try it out. At this point, I don't know whether it's working or not. So I could do some tests. So I could try to initialize the library, for example, and try to read the ADC and put a jumper wire to see if I can get the ADC to tell me a number that I can read easily. So for example, I could begin the AudioHacker Shield and then use read ADC 8-bit and then use that to print the value over the serial port and see how it looks like. For example, I'm going to try to do that just as a way to check whether the ADC works, because I'm not really sure whether the ADC works, and that's what really bothers me at this point. So let's see. And of course, yeah, my idea is that since there is an audio input here, I will just try to put like a 5 volts signal on either L or R and ground on the other one and see how it looks like. And in order to do that, I'm gonna just take a couple of jumper wires and connect them right away, like directly on the shield, and in that way troubleshoot the analog to digital converter. So I think I have some jumper wires just behind me. I will turn back and get them. Okay, here I am, and now I have a couple of jumper wires, as you see. So I'm going to connect one to 5 volts and one to ground, and I'm going to then connect them into the ground for the audio input and the signal. Ground and 5 volts, yeah. Wide is ground, yeah. So that's how it looks like. Okay, I just took 5 volts and ground from here, and I just put them directly in the inputs there. And I'm gonna check. I'm gonna make a very simple program from scratch that's gonna be taking calling the begin function, and then read ADC, and then try to print out the value. And I would like to know how this is done in one of the examples. So I will just open whatever example from the AudioHacker library and see how it looks like. So I will just take some sort of like sampler, like echo effect. Most likely we'll be reading some sort of sound. AudioHacker is using a lot of information, and we're not going to use that because we're not going to use the memory. We're just going to use the ADC. And where is this? Echo delay. AudioHacker, write DAC, and we have to have an ADC somewhere. Read RAM, even cycle. Oops. So this example is not reading anything. Oh, here it is, sorry. Read ADC. Okay, so basically it confirms what I want to do. So I want to just use read ADC, and then read ADC is done with this timer interrupt, and is basically reading interrupts on a timer. So every X amount of time, it's going to be reading it. It's going to be reading a signal, and it's going to be doing something out of it. So what I want to do is to use that idea to read the input of the ADC, but I'm not going to do it on a timer. I'm just going to do it in a very simple program, and then I'm going to be printing it out. So I just need a couple of things from this program that I have here, and I'm just going to take them into a completely new blank program. So I'm going to put this one here. And I have installed this very nice thing that makes Windows to work almost like like Linux, which is something that allows you to pin windows and leave them always on top. So I can work on a different window here, and you can still see the one I'm going to be making new. So we'll just copy this part, and somebody's saying something on the chat. I'm going to just put the chat in a different window so I can follow the chat. Yeah, there you go. It's nothing relevant. Okay, then I'm going to be in setup. I will use the serial port. I use a serial port, and I will start the use of the AudioHacker library. There you go, and then in the loop I can just call read ADC, and signal is going to be probably a long. Let's see, signal. Where is signal declared? I can see where signal is declared in the code. Unsigned integer signal. Okay, it's an integer. Okay, so I can just do it directly here, and I can call serial.println signal, and then I can call a delay of, for example, 100. So if this works as expected, what is going to happen is that I will be able of reading the ADC and print it out on the serial port, and in that way I would at least be able of check out whether this works properly. Right. So I will just save this example, because as you know, in my computer I cannot have anything on the temporary folder. I will make a new subfolder. And this will be test AudioHacker. Save. I will check that I have the right board, and the right board, compile it, have a sip of water, and If it compiles properly, I will upload it and then just run it to see whether it does what I want it to do. And if that's the case, then we know at least whether it's failing or not and why it's failing. And once I've tested that, I can check out other features of the library and see and slowly debug what is not working in my shield. Probably something that is not working has to do basically with my own usage of the thing. So as I was talking, I just uploaded the code, and I can just check on the serial monitor, and there you see the value, and it seems like it's working. Okay, I'm gonna change the voltage from I'm gonna change the voltage here by changing from 5 volts to 3.3 and see if that gives me a different reading. So let me just double check this, and you see I'm just pulling out 5 volts and taking 3.3 on the shield, and I go back to the desk, and you see I'm getting the exact same reading. So the analog to digital converter gives me the same reading for 5 volts as for 3.3 volts. I will change it again live. You can see as I change this, but you don't need to see this. And whoops, there you go. And I will try to change the input from being on the left channel of the input to be on the right channel of the input. And there you go. It doesn't affect, regardless of when I'm reading, or even if I just unplug the cables like I just did. I just unplug the cables. The readings I'm getting are the same. So something's not working. Something's not working here, and at this point I don't really know what it is. So I double checked whether the problem was with the analog to digital converter, like it was not plugged in the right place, whether it was a digital to analog converter wasn't plugged in the right place. So basically at this point I don't know what is happening. I don't know. I suspect that the DAC is not working. But let's see if it has to do with, for example, controlling the gain, because the value I'm getting is exactly the half of the absolute range. So I don't know if this is because it's a polarized measurement, so it has to be the half because it represents 0. And then if I change the gain on the DAC, I will then eventually get a different value. But I was putting 5 volts at the input of the DAC, and that should be enough to, you know, give some sort of reading. When I just change the gain, right now I'm just changing the gain directly, and I see no real change in the measurement. There is a slight change, but not really big. I'm gonna then just re-plug in. This thing I'm doing is not really correct, but I should be plugging off the power and reinitiate everything, but I'm just gonna do it live like this. And if I change the gain, like there is a slight change on the values, but it's like not really what I expect to see, because I expect to see a really big change, because I'm going from 0 volts to 5 volts, and then I should be getting a really big change in voltage, and this is not what I'm seeing, and it's not nice. So I wonder, maybe my jumper wires are wrong, so I can just change my jumper wires. I'm going to take 2 different jumper wires, because, you know, they are not super high quality, the ones I'm using, so might be the case that they aren't working. So I'm plugging them out, and I'm plugging in these new jumper wires. I'm going to put blue for ground and green for signal, and blue for ground and green for signal. And the measurement I'm getting is the exact same. So summarizing, if I read the analog to digital converter, when I put in a signal, I'm getting no reading, because I'm getting the exact same reading all the time, regardless of whether there is something connected or there is nothing connected, and so on. So this is not okay. So I'm going to double check again whether I plug in the chips in the right location, because it's the, in my opinion, might be the case I have a DAC instead of an ADC and something like that. So let's go back to the browser and just double check the part list. And let me just minimize, because you don't see what I see in the screen, so I'm actually seeing all of the other windows open. And if we are here, and this is the in the build, there's an explanation of the part list here, and okay, the ADC is the 3201C, and I will just unplug these cables, and C is the ADC, is down here, and the DAC is a 4921. 4921 is down here, and well, I wonder whether I basically switch them. So I can take a look back to the building guide, and the building guide very clearly, well, if you just look at the shield, because we don't have the original shield anymore because we mounted components on it, you just look at the shield, you see here it says DAC and here it says ADC. So the ADC is in the right location and the DAC is in the right location. So there is clearly something that is not working in either DAC or so probably on the ADC. So I'm going to try to fix this, to troubleshoot this by seeing which parts work and which parts don't work in the circuit in general, by slowly looking at different things step by step. So I just checked the ADC. So can I check the DAC somehow? That's a question. One thing I could do is to connect a wire from the output from the DAC to an analog pin down here, and write something to the DAC and try to read and see how it works. So this is one trick I'm going to do using a jumper wire and connecting ground and the output and connecting it to the ground and one input and see whether it works. So as you see, you can use your Arduino board to troubleshoot your own things. So here we have write DAC and seeing input or write DAC 8-bit. So I want to try to use the write DAC 8-bit, and so I can use a number between 0 and 255 to write to the DAC. And the actual value is okay, yeah, it's basically explaining the difference between using 8-bit and using 12-bit. Okay, I'm gonna use this one, and we go back to the Arduino software, and so this was the loop that I was using to read the ADC. So I'm gonna change this to read ADC, and I'm gonna just keep it there so I don't delete it, and I'm gonna make a new loop. This keyboard is new, so I will master it, and I'm gonna use this write 8-bit, and the thing I'm gonna do is I'm gonna have a counter so that I can see whether the voltage is changing slowly. So for int I equals 0 while I smaller than 255, I plus equal 10, so I will have like not have to wait the whole scale, and here I will write just I to the line and make a small delay of like 100 milliseconds and have to close. And before doing this, so I write a value and then I'm gonna be reading. We just have an integer val equals analog read A5. I will use A5 as I could use anything else, and I will print out the value that I read. So if this works fine, as I will be writing something to the DAC, I will be able to reading it and printing it out. Okay, so I will just upload this to the board, and I will prepare my jumper wires so that I can okay. Oh, sorry. I have to call it with the AudioHacker object, so it has to be this way. Okay, now the sketch is running, and if it's running properly, I can open the serial port monitor, and by default it's reading the value 19. I'm gonna try to capture the output and ground as it is in the connector. You can see as I'm doing this here, ground is blue, signal is green, ground is blue, and signal goes to A5. And as you see, in the readings, the value I'm getting all the time is oh my god, I made a mistake in my program. Nobody said anything. So I'm reading the value in my program. Look at this, and I'm printing out the A5, which is actually number 19. I just a bit tired today, so let's just change this and upload it again, and now we can print out the value that we are reading. So now it's reading a 0 all the time. So basically I'm reading the analog value, even though I'm changing the value all the time. I'm writing the DAC to be a different value all the time. I'm reading it, and I'm reading 0 all the time. So this is not exactly doing what I expect it to do. So I would expect it to do, so when I write the value, sorry, when I write the value to the DAC, if I measure the value, I should be measuring a constant value. But this is unfortunately not the case. I will do something. I will just change the delay and make it slightly bigger, and make it change like a lot bigger. So every second it will increase 100 units. So I should see something like 0, 120 something, 200 something on the serial port monitor. This is what I should see, but it's not what I'm gonna see, because I suspect that this is not going to work once more. Okay, so reaching this point, I know that with the current status of things, I cannot read the ADC and I cannot read the DAC. So where is the problem in my current system? There must be a problem somewhere, and I don't know what it is. So this is status for now, and as I said, I'm going to be making 1 hour LiveCast this week, trying to learn about how to use this shield, and I'm at the end of my second hour, or my first hour this week, second hour in this project. So at this point, I'm going to call for a day, and I will come back tomorrow and continue to work with this shield, trying to figure out what is not working in it. So you can take this as an introduction to how to troubleshoot. If you have never been really trying to troubleshoot different things, you can take this as a way to how to troubleshoot different designs. So I'm going to leave everything as it is now. Tomorrow you will find it exactly like this, and I will just continue where I left it. I will continue to check in which step I stopped. Sorry. So this is the state of things. At this point, I have two shields. One of them is pretty passive. It's a bunch of buttons and potentiometers, so I'm not checking it out. The other one is quite complex. It has an ADC, it has a DAC, and it has memory and a sound amplifier. So right now I try to read data written with the DAC, and just before I try to read data using the ADC and print it out on the serial port, and none of those worked. So the question for tomorrow is, what is not working here? So it looks almost as if there was no power reaching to the microchips. Did I solder something wrong? So I will figure this tomorrow. So thank you very much for watching, and I hope you're enjoying this. It's a live troubleshooting session on the Arduino LiveCast channel. So thank you very much, and see you tomorrow. Good night.